And everything in that equation that I just wrote, the HI and the H2 and an I2, it's all a gas. I'm just not going to write it because it's just sloppy. Alrighty. To work this problem, we're going to set something up called an ICE table. So I'm going to label the left-hand side over here as I, C, and E. And let me tell you what that means. I means initial. C means change. And E means what? Equilibrium. E means equilibrium. This question asks for the equilibrium constant. In order to calculate the equilibrium constant, then I'm going to need to know the equilibrium concentrations of all the components. Am I not? I'm going to need all this stuff at the bottom. Because to calculate the equilibrium constant, can't I say products over reactants raised to the power of their coefficient if I know all their concentrations? I can. So read the problem with me. If it's filled with 0.2 moles of HI, and it's a 1 liter flask, then isn't that the same as 0.2 molar? Because molar is moles per liter. So the moles and the molarity are the same thing. Do you guys see from reading that problem that the 0.200 moles, obviously it goes with the HI, but do you also see that it is the initial amount of HI? Do you see that from reading the problem? Promise you see that? Yeah. Because it says the reaction is allowed to proceed to reach equilibrium. So that's my initial amount of HI. Where does that 0.078 molar, where does that go in the table? Equilibrium. The problem says that is the equilibrium concentration, so that goes right here on the equilibrium line for the HI. So right now, I have one number that I need to calculate the equilibrium constant. That's all the information that I get from the problem. The rest I'm going to have to come up with. First of all, if the problem tells you you're starting with 0.2 moles of HI and it doesn't tell you anything about the hydrogen or the iodine, then you get to assume that initially there's none of those present. If I know I start with 0.2 HI and I know I end with 0.078 HI, can I figure out how much that changed? How would I do that? I could simply subtract them, take the difference, right, between 0.2 and 0.078, and when I subtract those, I get 0.122. So I know that right here I have used 0.122. And I'm going to put a negative there because I know it was used. How do I know it was used up? Well, doesn't it make sense to you? I couldn't have made it. I didn't have anything to make it with. Right? There was no hydrogen and iodine in there. So you okay with the 0.122 number? Sure. All right, there's something special about this change line. And what's special about the change line, and only the C line, y'all, is that the numbers on the line for C, they will follow along with the coefficients. In other words, if the coefficients are like here, 2, 1, and 1, then I have to have the same ratio of numbers on that C line. So if I can get one number on the C line, and I just did, well, I know 2 of these for one of these. So I know if this is 0.122, this has to be what? That's got to be 0.061. How do I know that? Because I'm following the coefficients. No, this is not negative, because if I start with 0, can I use up any of 0? If I don't have any, can I use any of it? No. How did I get 0.061? I knew that two HIs will make one hydrogen. So if I'm using 0.122 HIs, then this would be 0.061. I used the coefficients. What's that?
Does that mean I2 is 0.0612?
Exactly. Since hydrogen and iodine have the same coefficient, I now know that I2 is also 0.061. How do you know if they're positive or negative? It's always going to be negative on one side of the equation and positive on the other. Because you can't have all your reactants and products all being used up, can you? If you're going to use them on one side, you've got to make them on the other. So if I started with 0 hydrogen and I produced 0.061 molar hydrogen, then don't I know at equilibrium this is going to be 0.061 as well. How did I get that? Right, I just added these two together, didn't I? And so I can add these two together and I know what this one is. I'm writing it in fat ink so y'all can see it over that little watermark. Then what do I need to do? Don't I now have all the equilibrium concentrations? Can I not now calculate the equilibrium constant? Can I change slides, y'all? Go ahead.
Everything on the reactant side gets subtracted and everything on the product side gets added to find the equilibrium.
In this one, yes. If your flask starts off with reactant, you're going to use it. But I could have said initially I put H and I together. So that means I'd be starting with amounts here. So I'd have to subtract. And you don't usually have a lot where you start with products. But so for the equilibrium constant, Kc, I'm going to take the concentration of hydrogen, which is 0.061, times the concentration of iodine, which is also 0.061. And I'm going to divide that by the concentration of HI, which is 0.078. But I've got to remember that I square that, right? Because the coefficient of HI was 2. .612?
Yes.
Is that what y'all got?
Is there units?
No. Equilibrium constants do not have units.